We are recording. Can we go over how to find range and domain when given an equation? Yes. Okay. So if you're given an equation, you're going to look for a few things. For domain, you're going to look for two things. You're going to look for, is there a variable in the denominator? And if there is, then you need to set the denominator. The denominator, you can't divide by 0. So if you've got a variable in the denominator, then you need to set the denominator equal to 0 and then solve for x. The other thing you need to look for is there a variable under a rad? Let me make that more clear. Under an even indexed radical. Because a cube root, it doesn't matter. But a square root or a fourth root, you need to make sure that what's underneath the rad, so what's underneath there, must be greater than or equal to 0. And if you don't have either of those two things, then your domain is all real numbers. All real. For range, you need to look for a couple of things, a little more. You need to look for if there is no variable, if you've got like a fraction, if there's no variable up top in the numerator. Well, then your y will never equal 0. The range will never equal 0 if there's no variable up in the numerator. If you've got the equation y equals some kind of x blah 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 to an even power, x squared, things like that, then you're only going to get positive y values. X must be greater than or equal to 0. And then what else? If you've got y equals, something, some kind of absolute value of something, well, y will always be greater than or equal to 0. What else? Y equals the square root of something. Well, y is only going to be greater than or equal to 0. And then if not any of these, then your range is all real numbers. Okay, so we could do, did we have some of that on, yeah, so like on the quiz, did you guys put any of that? No, but we can still do it. Okay, so still talking about domain and range, right? Quiz number 11. Let's go. 11a has f of x equals 2 over x cubed. All right, so we talk about domain. You look and see, oh, look. Is there a variable in the denominator? There is, and so you need to set the denominator cannot equal 0. So that means x cubed cannot equal 0. Taking the cube root of both sides, you're going to get x can't equal 0. Hang on 1 second. Okay, so that's your domain. X cannot equal 0. Technically, the mathy way of writing it is the set of x's such that x cannot equal 0. I'm okay with you just writing x can't equal 0. I'm not sure about all the other teachers, what their rules are on that, but that's your domain. And then range, if you notice, there is no variable in the up top. There's no variable in the numerator. And so y cannot equal 0. Down in the bottom, we've got an x cubed. So there's no restrictions on x cubed. We can have all kinds of y values, negative, positive, and all of that. And so it's y can't equal 0. Technically, it's the set of all y values such that y cannot equal 0. Again, if you're my student, you can just do it like this. Hopefully, if you have Dunkel or Barker or Fox, they told you how they wanted your answers. And then if we did 11b, we'll go to a new page. So this is still 11b. We've got g of x is equal to the square root of x minus 3. And so you don't have a variable in the denominator, you do have the square root of something. And so it's what's underneath the square root, this guy here, needs to be greater than or equal to 0. So we've got x minus 3 must be greater than or equal to 0, which means x must be greater than or equal to 3. There's your domain. And technically that's x is such that x is greater than or equal to 3. And then range, notice that you have y is equal to the square root of something. And so your y values are all going to be positive values. Because the very smallest thing, you're plugging in 3 and numbers bigger than 3 into x. And so the smallest value y will be a 0, and then it just increases from there. The technical, all the set of y such that y is greater than or equal to 0. If you graph this using transformations, y equals the square root of x looks like the upper half of a sideways opening parabola. And so using transformations, this is a shift. Let's use better words. This is a horizontal shift right 3 units. No other shift up or down or a reflection or anything like that. And so 1, 2, 3, it would be here, and then going up, and then you can look at that graph and see, oh yeah, it totally makes sense that your domain is all your x values. 3 is the most left x value, and then it's going to the right forever and ever. And then for your range, it's the y values, and the smallest y value is 0, and then it's increasing slowly, but it is increasing and going to infinity and beyond in positive directions. Okay, hopefully that makes sense for domain and range. Let me just do a couple more just because just never know. What if you had, I'm just making crap up right now, 1 over the square root of x minus 3, right? So your domain, start with that, you've got a variable in the denominator, so you can't have, your denominator can't equal 0. So that means you've got the square root of x minus 3 cannot equal 0. And if you square both sides, you have x minus 3 can't equal 0. And so x cannot equal 3 because you can't divide by 0. And yet you also have a radical. And so you also have that what's underneath the radical must be greater than or equal to 0, which means it's x can't equal 3, and at the same time, it must be greater than or equal to 3. And so putting both of these together, your domain ends up being that x must be strictly greater than 3. That's how you do it when there's, both a variable in the denominator and at the same time, you've got an inequality happening as well. I'm sorry, not an inequality, a radical, right? You've got a variable under the rad. So that's how you handle that. And then your range, you've got a number up top, so y cannot equal 0 because of the number up top, but then you also have a radical, so and y must be greater than or equal to 0, right? Because you're doing y equals, you've got a radical there, and so putting both of those together means your range ends up being that y is strictly greater than 0. It won't actually equal 0. Hopefully that makes sense. Let me think what else we could throw at you. Hopefully you had some homework ones where maybe, what if it was like a y equals a negative square root of x? Yeah. So that means your graph is the lower half of a sideways opening parabola. And so my rules still work, but then you got to keep in mind that there's been some kind of transformation, right? That negative in front flipped it upside down. And so on this guy, your domain would still be x must be greater than or equal to 0, because that's what's underneath the radical. Your range, if it was just a positive square root of x, you're going to have y is greater than or equal to 0, but this negative makes it be a y is less than or equal to 0. So make sure you pay attention to that. A negative in front will flip it, reflect it across the x-axis, and so it ends up making it negative y values. Which if you think about the transformation, which is what we were doing all chapter, right? Y equals positive rad x looks like the upper half, and so y equals negative rad x reflects it, and so that's where it's this graph there. Okay, hopefully that made sense. We've got number 14 on the quiz. Was that the next one? No, page 114, number 2. And then 14 on the quiz will be next. 114, number 2. All right, so we want to determine symmetries. Okay. So page 114, number 2 says y equals the absolute value of x minus 2. I want you to determine the symmetries and then use the properties of symmetries to graph. Okay, so is it symmetric with respect to the, let's start with, actually, I'll do the same thing that was on your quiz and go x-axis first. Okay, is it symmetric with respect to the x-axis? And what you do to check if it's symmetric with respect to the x-axis is you plug in a negative y into y. So negative y equals absolute value of x minus 2. And you want to see, can you get it to be equivalent? And the only thing you could do is plug it, you could divide both sides by a -1, and you could have a negative in front there, but that negative does not distribute inside an absolute value, and so this is not equivalent. And so this is a no. It is not symmetric with respect to the x-axis. To check if it's symmetric to the y-axis, you need to plug in a negative x into x. So we got y equals absolute value of negative x minus 2. What could you do? You could do and factor out a negative like that, but you'd have to factor it out of both. Yeah. And so, and then if you take the absolute value of that, you'll end up with a y equals, will that work? Let's see. If we do a 3, yeah, it'll end up equaling the same thing as absolute value of x plus 2. It's not equivalent, so that's also a no. To check if it's symmetric with respect to the origin, you plug in a negative x and a negative y. and you try to see if you can simplify it. You could do the same thing with the whole negative, but it's still inside of the absolute value. So you'd have a, that's equivalent, but then you could throw the negative in front. Anyway, this is also not equivalent. So there were no not symmetrical to any of those, to the x-axis, y-axis, or origin. Not symmetric to x-axis, y-axis, or the origin. And then you could see that too. Hopefully you remember absolute value is the v. X minus 2 inside parentheses means it's been shifted right 2 units, but then it's still a v. So there is symmetry in this, but it's symmetric with respect to the line x equals 2, if you see that, right? Here's your line of symmetry now, is through x equals 2. So it's not symmetrical with respect to the x-axis, y-axis, or origin. It has symmetry, it's just not to any of these axes. And hopefully that made sense. Okay. What's next? Let me scroll down. Number 14 on the quiz. Okay, so they want you to determine the open intervals in which the graph is increasing, decreasing, or constant. And the graph they gave you looked like this. Okay, sorry, it's messy, but here's what the graph looked like. Okay, so when you're talking about increasing, decreasing, or constant, you always look at the graph from left to right. So, because it's always as x is increasing, right? And so as you're going this way, you can see that your y values are getting smaller, 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 smaller until you reach right here, right? And then you start from this value, you start going and your y values are getting bigger, 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 so that's increasing. And then from this value to the right, it's staying constant. So you're always looking from left to right, and you're looking at, are your y values getting bigger or smaller? The other thing is, when they say open intervals, even if they are closed dots, you're still going to use soft parentheses, and you're going to write leftmost x value, comma, rightmost x value. So my point to that is, you do not use y values at all when you're giving these open intervals where the graph is increasing, decreasing, or constant. You're giving x values for where the graph is increasing, decreasing, or constant. So let's talk about, which one was first? Increasing first. Okay, so it's increasing along the red part of my graph there that I colored in, and you're looking at x values. So that means you're going from -1 until +1 is the part where your graph is going up as you're going from left to right. And so your answer is from -1 to +1, because you're only giving me x values. Decreasing was the green part of the graph, right? And so it's this guy, you're going down, 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 down. Well, you're going down for what x values? Well, the most right x value was here at -1, but then, and it's going forever and ever, all of the x values to the left there because of this arrow going forever to the left. And so your answer is, it never ends going to the left, so it's a negative infinity. That's your leftmost x value, because there isn't a leftmost. And then all the way until you reach 1. No, -1, not +1. And then constant is when it's a straight horizontal line, right? And so that's the gray part of the graph. And so you're going constant from here all the way to the right, and those x values are from +1 going forever to infinity and beyond on to the right. And so it's a 1, infinity. So you do not write any y values on these guys at all. All right, hopefully that made sense. Page 51, number 12. Domain and range. Okay, so start with domain. You've got a variable in the denominator, so you need to set the denominator not equal to 0. And so x plus 2 cannot equal 0, and so x cannot equal -2. There's what I would say the domain. Your teacher may require you to be writing x such that x cannot equal -2. I don't think anyone is doing interval notation yet. That's your domain. There's no rad, so it's just the whole denominator dividing by 0. You've got to avoid that. The range, you've got a number up there up top. There's no x, there's no variable in the numerator or up top. And so that means that y can never equal 0. It's never going to happen. The bottom is just an x plus 2, and there's no restrictions on that at all. You could have negative values, positive values, whatever. And so that's your range. And just in case, it's the set of y values such that y cannot equal 0. All right, that was page 51, number 12. Okay. Number 1186. Okay. Page 86, number 11. During an energy crisis, the price of unleaded gasoline had increased at a constant rate of 5 cents per gallon per week for 8 weeks. At the end of the 8th week, the price had reached $1.65 per gallon. Find an equation in standard form given the price of gasoline as a linear function of time and draw the graph. The price of unleaded gasoline had increased at a constant rate, so it increased at a rate of 5 cents per gallon, 0.05 per gallon per week. And then for 8 weeks. And at the end of the 8th week, at week 8, it was $1.65 per gallon. Oh, if only. Oh, can you imagine? It just shows how old this freaking book is. $1.65 per gallon. Find an equation in standard form. Okay. All right, so increasing at a rate of 0.05 gallon per week. That, what they gave you, it's increasing at a constant rate, right? That's your slope. And then they gave you that week 8 was $1.65 per gallon. Okay, now they say find an equation in standard form giving the price of gasoline as a function, as a linear function of time. Okay, so price is going to be your y value, and x is going to be your time value. Here's what I showed my students. I'm going to go to a different slide real quick. You know y equals f of x, right? We know this, y is f of x. And so in words, this is y is a function of x. That's how you say that in words. Y is a function of x. And so when they tell you find an equation in standard form giving the price of gasoline as a function of time, right, then time is your x, price is your y. Keep in mind, all ordered pairs are written as x comma y. So time is going to be your x and price is going to be your y when you write an ordered pair. Okay, that's how I figure out which one's x and which one's y. I'm going to go back to that slide and finish this problem. Okay, so that means that at week 8, you have a price of $1.65. So there's your point. And then we have the slope is 0.05. And so using point slope form, which is y minus y1 equals n times x minus x1, that'll give you y minus 1.65 is equal to 0.05 times x minus 8. They want you in standard form, so that means you are going to we're going to go, why didn't they get a y? Why did they? Because they went straight up for frickety fracketer. Why did they do that? The price. No, I'm fine. All right, so y, you're going to just simplify this. You'll get a 0.05x and then an 8 times 0.05. Is that 4? No, it's 0.4. And then we'll add the y equals 0.05x plus 2.05. I guess I would do that. No, I must have made a mistake. No, not. Sorry, because I can't add obvi. Dum da dum dum. Bum 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 bum. Forget like that just happened. We're doing negative 0.4 plus 1.65, which is 1.25. Plus 1.25. This is how you're going to need to write it, I believe. Just make sure. They put it into standard form. I think that, just double check. Double check. Oh, I'm wrong. We're going to fix it. Okay. Okay, so we've got that. I'm going to go to the next slide. I've got y equals 0.05x plus a 1.25. You need standard form. Standard form would be ax plus by. This book does plus c equals 0. And so I would get, and then your A needs to be positive and no fractions, which means no decimals. So I would go and move the decimal place. Okay, so I'm going to go and multiply everything by 100. So that'll give you a 100y equals 5x plus 125 to move the decimal place over 2 places. And then rewriting this in standard form, it would be a 5x minus 100y plus 125 equals 0. So yeah, you'll have to do the same thing, put it in standard form. So keep in mind, ax plus by plus c equals 0, and your a needs to be positive, and no fractions for b, for a, b, or c. Yeah, I think they're wrong. I noticed that the book didn't have that either. The only thing I can think of is when I first set up the thing, is there a reason why? Did they tell us what units it should be in? During the price of unleaded had increased at a constant rate of 5 cents per gallon per week for 8 weeks. At the end of the 8th week, the price had reached $1.65 per gallon. Find an equation in standard form given the price of the gallon. I think they're wrong, which wouldn't be the first time. Or maybe I made a mistake somewhere, but I don't see where. I think that they could have just multiplied it by 100 right off the bat when we first got the coordinates. True. But let's see. Let me just double check something really quick. This was page 86. It was number 11. Yeah, what they did was they went straight up for, they got rid of the decimals immediately, versus I did not. I kept the decimals, but 0. I think either answer should be fine, is what will happen. Is that right? No, because I have a 5x. I think they're wrong. But whatever. We'll just move on. You will not have the same issue on your test. So sorry for, hopefully that was not confusing. Okay, so let me go back up. That was 11 on 86, so we're back on page 51, number 22. Find the inverse function. Okay, so if g of x equals 1 over x plus 2, find the inverse function. Restrict the domain of the original if necessary. I don't think that's necessary. Okay. I'm going to replace g of x with y. I'm going to switch my x and my y. And then I want to solve for y. So you need y by itself on one side of the equal sign, right? And everything else on the other. And so this one is more confusing because you're like, wait, but y is all by it, is, on the one side of the equal sign. So you actually have to do, kind of go against what your gut tells you to do. And so what you're going to do is, I'm actually going to multiply both sides by the y plus 2. And we're going to get an x times y and a 2 times x. And then the right-hand side is just a 1, because these two guys canceled. And then what you want to do is get any term with y in it by itself on this side of the equal sign, and so I'm going to subtract the 2x from both sides. And then you want to solve for y by dividing by x. And so I would have written my answer as, I think they wrote it a little bit different, but g inverse of x is equal to, I'm fine with you leaving it like 1 minus 2x over x. That's fine. It looks like they wrote their answer as 1 over x minus 2. That would be fine too. All they did was separate the fraction or whatever. So, what does it say? It says, restrict the domain of the original. I don't think you're going to need to worry about that tomorrow because it's domain and range is already so complicated for you guys, and you already have a hard enough time with it that you're not going to need to worry about, no, you don't need to worry about restricting. I mean, technically the domain here, x can't equal -2, right? And so, it's not going to be able to either on the inverse, and anyway, so, but don't worry about, just don't worry about that one, about restricting it. Okay, same page, number 26. Boop, boop, boop. All right, we've got g of x is equal to greatest integer function of x, and then plus 2. I would use transformations on this. Y equals greatest integer function of x. It's going to be closed out on the 0, open on the 1, stair step, right? And then closed, open, stair step, closed, open, stair step, and then it keeps on going like that. Open, closed on the left, open, closed. Okay, so here's your parent graph, right? So that's the parent graph, is that guy. And so what does this do? It takes that parent graph and it does a vertical shift up 2 units. And so now instead of it being at, like, starting at the origin 0, 0, you are going to be here. Open, and then closed, open, and closed, open, and then you just keep on following that pattern. Open on the right, closed on the left, stair step, open, closed, stair step, open, closed, stair step. So all you're going to do is just shift the whole thing up 2 units. Okay, so how do you know it's up 2 and not down 2? It's this was up 2 because it's outside of the parentheses or grouping symbols. If it had been g of x equals, and you had an x plus 2 inside of the grouping symbols, this is a horizontal shift. Opposite in sign when it's horizontal, when it's inside, so this would be left 2 units. If you were to do a flip of the parent graph, how would the graph change? It would be a reflection across the x-axis. So if you can imagine flipping this upside down, this guy, here, I'll do it in a different color because I really don't want to have to redraw all of this stuff. But so if it was a y equals negative, right? You would do a reflection across the x-axis, and so it's still, just make sure this would be a flip. So this would be a doot, 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 and a doot, 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 and a whoop, open, doot, and then you've reflected. So now this is open, close, straight, open, closed. Yeah? The green one is the reflect across the x-axis. It's been flipped upside down, right? Imagine it and then flip it upside down. There you go. Okay, go back up. So that was 51, number 20, page 51, 26. Okay. Can you explain how and when to restrict the domains? You don't have to worry about it. I told you that. Can we do a problem where we need to determine the piecewise function for the graph? Sure. Find me a problem. Number 33, page 42. Determine whether f of x and g of x are inverses of each other. I'm going to skip that one if that's all right with you guys, just because I see you got a huge list and we only have, what, how long do we have? We have 20 minutes left, and if we still have time at the end, I'll come back to that one, but you are not going to need to be going back and forth like that. I don't see it. Okay. So I'm skipping that. 16 on page 49. I'm going to skip that one too. If we have more time, I can do it. We need to definitely do difference quotient because you guys suck at them. Let me find one. Preferably when you guys come in here, you give me problems to actually do. So how about, let's see, there was a group quiz. Let's do the group quiz one. Okay. Let's do the group quiz. What is that? Number 8. We only have a limited amount of time, so making me come up with the actual problems to do just doesn't work. You need to actually give me problems instead of just saying that. Okay. All right. If f of x is equal to x squared plus 5, and they want you to find the difference quotient, which is f of x plus h minus f of x all over h. All right. So here's the dealio. Let me go to a different page real quick. If f of x is equal to x squared plus 5, what's f of heart? Well, you guys are like, oh, Mrs. Bright, that's so easy. You just plug heart into x and then you square it, right? And if I did, all right, what's f of smiley face? Well, it's smiley face squared plus 5. Okay, well then, what's f of heart plus smiley face? Like, Mrs. Bright, come on, this is too easy. Heart plus smiley face, quantity squared plus 5. And then I throw real math at you and go, okay, what's f of x plus h? And y'all mess it all up. It's blah, blah squared plus 5. And you put whatever is in this parenthesis, it happens to be x plus h, inside of, you know, this guy, x and x, right? Whatever is inside there is what gets plugged in. So I'm plugging in an x plus h there. Okay. So let me go back to the screen. This is equal to, we're going to plug in an x plus h into our function. So it's a blah blah squared plus 5. But what I'm plugging in is an x plus h. So that part was only this part right here, right there. Okay. Then I've got a minus, and we're going to do minus f of x, right? Now, you're subtracting, and your f of x is a binomial, so you've got to put parentheses around it. Super important. If you don't, you're going to mess it all up. And then that's all over h. Okay. Then we do algebra. Now, you do need to remember that when you square x plus h, it's x squared plus 2xh plus h squared. You got to remember there is a middle term there, and there's a 2 in front there. And then you still have the plus 5. You need to distribute this minus sign into both of those guys. So a minus x squared and a minus 5 all over h. Here's your biggest hint, okay? Everything without an h in it right now better cancel, or else you did something wrong. So x squared in this first term better cancel because there's no h in it, and it does. There's a minus x squared right there. You should have opposite in sign for things to cancel. Second term, 2x plus h has an, or 2xh and an h squared. Both of those have h's. 5 minus 5. Those guys cancel. They all need to cancel because the h in the denominator will absolutely cancel every single time you do this. So I'm going to factor out the h that's in common. I would be left with a 2x plus h. These h's cancel, and your answer is 2x plus h. If you're getting a final answer of 1, you're doing it completely wrong. I don't give you any, I don't even give you a pity point, if that exists. But I don't even go, oh, they kind of sort of knew what they were doing. No, if you get an answer of 1, you are absolutely doing it completely wrong, and I don't give you anything. So just make sure if you're getting equals 1, what you're doing. So the difference quotient should not equal a 1. I mean, again, there's like one case where it does, but you're not going to see it. What you're doing there, so f of x plus h minus f of x, or here, f of x plus h is not, let's go back to, actually, let me go back to here. Okay. You know how we plugged in x plus h into your x squared? It is not equal to, let me do this in red. It is not, definitely not equal to x squared plus 5 plus h. If you're doing all of your problem and you simplify and you end up getting your final answer for the difference quotient is equal to 1, that's what you did. And I give you 0 points, not a 1, because that's completely wrong. You don't know what the heck you're doing. So no points at all. So don't do that, okay? Plug in and, okay. There's a difference quotient. There's the whole problem with the thing. Okay, 9 from the quiz. Quiz number 9. Find the inverse. Yeah, this one's complicated too, huh? It's very similar to the one I did, but this one's even more complicated than the other inverse one I did. Okay, find the inverse. So your first step is replace f of x with y. And then switch your x and y. So you get x equals 4y over 3y minus 2. All right, so the problem is that you need to solve for y, right? And you need one y and then everything else on the other side. And yeah, you're going to do the same thing that we did on the last one, where what you end up having to do is do something that doesn't feel natural, like this doesn't feel right. It feels like you're making more of a mess, but you got to make it messier to clean it up. You're going to get rid of this denominator by multiplying both sides by 3, by the denominator, by 3y minus 2, so that these guys cancel. And you're going to distribute the x into both of these two so that you get a 3xy minus 2x equals 4y. And then you're like, but Mrs. Bright, now we have two y's and they're on two sides of the equal sign. Yeah, but we can fix that because I can subtract the 4y from both sides, and I can add the 2x to both sides. And now that I have I've got more than one y there, right? But they're all on the same side and only separated by a plus or a minus sign. That's your goal, is to get it into, instead of a y divided by a y, you need it to be a y plus or minus a y. Terms with y's in it, they need to be separated by plus or minus signs instead of by division. Okay, so why do I do that? Because now I can factor out the y that's in common to both of those terms, and I'm left with a 3x minus 4, and then dividing both sides by the 3x minus 4 will give you 2x over 3x minus 4. And then, of course, write your inverse notation. So that was the answer I came up with. Some of my students, instead of, they did it all right and they got the correct answer. Their answer looks a little bit different from mine because they, instead of like subtracting the 4y and adding the 2x, they subtracted the 3xy. Anyway, so your other answer could have been, if you had a negative 2x up top, it would be a positive 4 and a minus 3x. That one is fine as well. That's equivalent. So, and that would have just been from subtracting a different way. All right, that is quiz number 9. Okay, answered that. I'm going to skip that question. Doop-a-doop-boo-boo. Yep, okay, good. If an equation is y equals x plus 3, is it moving up? And then if it was x plus 3, it would move to the left. Okay, so CL. No, and here's why. Well, let's see. Y equals x plus 3. Actually, okay, so yes, you're absolutely right. You can do, it does both on this one. This is unique, and it's only because x plus 3 with no parentheses on it and y equals x plus 3 are the same graph. You don't need parentheses around this x plus 3. And so is it a shift up 3 or is it a shift left 3? It's both. Because you could think of it both ways, but I don't want to confuse y'all. But it's only unique to this guy. The line y equals x looks like this, right? And so if I do y equals x plus 3, it actually goes to the point 0, 3. It also goes to the point negative 3, 0. And so you could think of it as taking this straight diagonal line, and you could think of it as shifting it left 3 units, or you could think of it as shifting it up 3 units. But most equations don't do that. Like, it's only because this is linear and doing the one shift happens to do the same. So it's a unique problem. What you really are going to see are things like you need to know the difference between this versus that. Okay, that really is a true difference of, this is a shift up 3 units and still a V, and this is a shift left 3 units and still a v. So definitely a huge difference there. Also, y equals x, let me stay consistent with doing vertical and then, come on, one more, boop, boop. There we go. And x squared plus 3 versus a y equals x plus 3 quantity squared. This guy is a parabola being shifted up 3 units versus this is a parabola being shifted left 3 units. So it's very rare for the example you came up with, but it's because the with parentheses or without the parentheses, it's the equivalent equation. The same thing. Okay. For page 49, number 16. Nope, I'm skipping it. Do the first problem on the quiz. That's a good one to do. Make sure you show your work. Really? I mean, we're not going to give you points for being able to, you got a 50-50 shot on guessing if it's yes or no, right? So you absolutely have to show the work. So the function is x squared y equals 1. To check if it's symmetric with respect to the x-axis, you're going to plug in a negative y into your function. So we've got x squared times negative y equals 1. And then you simplify it to see, like, can it be simplified so that it looks identical or equivalent to the original problem? And, you know, the only thing you could do when you simplify this is it's a negative out front, x squared times y equals 1, and so this is a no. There's no simplifying that could happen that would make it equivalent to the original. Is it symmetric with respect to the y-axis? And for that, you're going to plug in a negative x into x. Whenever you plug in something into a variable, you put parentheses around it. So now I've got a negative x quantity squared times y equals 1. And a negative x quantity squared is a positive x squared. And that is a big ol' yes, because that is equivalent to the original equation. And then for the origin, you need to plug in a negative x and a negative y. So you go negative x quantity squared times negative y. And the negative x quantity squared will be in positive x squared, but you still have this times negative y, and so it's a negative x squared y, and so that is a no. So it is symmetric with respect to the x-axis, but, or sorry, to the y-axis, but not to the x-axis or to the origin. And then to figure out if it's odd, even, or neither, I'm going to rewrite the equation. You see that I could rewrite this as y equals 1 over x squared. And y is the same thing as f of x. So this is an f of x equals 1 over x squared. And to figure out even, odd, or neither, you need to plug in a negative x into x. And I would have a 1 over negative x quantity squared. And that becomes a 1 over positive x squared, which is equivalent to my original f of x, which means it's even. It is an even function. Does the exponent being an even number have anything to do with it being even? Yes, that is not a coincidence. Like if it was x to the third times y equals 1, the function would be odd. The function, I don't think it'll be odd, but it'll be origin. Oh, I see what you're saying. Okay, so would it be odd? Plugging in a negative x would give you, yes, sorry, I'm being a doofus right now. I was thinking the symmetry. So if it was x cubed y equals 1, the symmetry would be symmetric with respect to the origin, right? Because plugging in a negative x and a negative y would give you the original. And then would it be odd? Yeah, because you plug in a negative x and you would get a negative y or a negative f of x. And so yeah, it's not a coincidence. I mean, there are some, you have to be kind of careful because there are some more bizarre equations out there. But yes, in general, most of the time when it's got an even exponent, then it's going to be even, and when it's got an odd exponent, it'll be odd. But, you know, we can make it more complicated of, hey, what if there's a cubed and a squared in the problem, in the thing, right? We could give you a fraction and have more than one exponent on it, or we could give you absolute value, and then it's not so obvious. So make sure you know these, plugging in the right negative x or negative y and all of that. But yeah, it's definitely not a coincidence that happens. What time are we at? We are at 6:02. I see people typing, but I think I got started on time. If there's anything really, if it's like a really super quick question, I can do it, but otherwise I will sign off. Would y equals -2 flip over the x-axis and would, yes, but you know, yes, it's a flip over the x-axis, right? It's going to be an upside down v, and it's going to be skinnier, right? But look at y equals absolute value of -2x, yeah, inside. So would it flip over the y-axis? Yeah, technically, but do you see that this is equivalent to that, which is also equivalent to this? The absolute value of -2 is +2, and 2 doesn't affect it. And so the graph of this is this. And so if you flip it over the y-axis, it still looks like a v, right? So yes, technically, when it's definitely when you've got a negative inside of like the parentheses and stuff like that, then it'll be a reflection over that. But sometimes when it's symmetric like that, then it looks identical. So, alrighty. I'm going to call it. I'm going to stop the recording. I'll put the link to the recording in this window down here, and good luck.